And anyone remembers the definition of correlation coefficients?
Is that the covariance of xy over square root of the variance of x times variance of y?
Yeah, so
I was gonna
basically
say
it's the
that.
covariance of this divided by the standard deviation of x, standard deviation of y. Okay, so that's what we have in this part. Now, when you do this linear regression, I didn't cover that part because we were short of time. So normally you start with one more thing. Now, corresponding to this, there's a sample correlation. So what is a sample correlation? Sample correlation may normally denote by R. That is basically on the top is sample covariance. Sample covariance, you think that you have what? Sort of xi minus x bar, yi minus y bar, and you need to divide by n minus 1 to make it unbiased, right? But then in the bottom, you really have the similar kind of thing. You also have this. This is the square. Then you take the square root of that. And you take the square root of this. But you see that 1 over n minus 1 actually appears everywhere. So you can take out this. So it's pretty much like that. Because it's a 1 over n minus 1 here, 1 over n minus 1 here. Those two together give you a square. Take out the 1 over n minus 1 on the top. So it becomes something like this. So in general, when you do the linear regression, what you do is you first check this. Because you have a two set of the data. One side is xi, the other one is yi. So you first compute the correlation coefficients for the samples. Whenever that quantity is close to 1, you have a high linear relationship. So for linear regression, you always start this. We start with computing sample correlation coefficients. If this R is close to 1 or minus 1, then there is a strong linear relationship. If it's something like a 0.2, you wouldn't do the linear regression to begin with. That tells you you really don't have a strong linear relation. You may have something else. So normally, what is considered to be high? 0.8, 0.7 something is maybe not that high, but it's still pretty high. It could be negative value, right? Either positive or negative. Positive meaning you have a slope, it's going this way. If it's negative, going the other way. You have an inverse proportional kind of thing. So that's one thing I should add for the linear regression part. You always start with this. By the way, this can be easily computed because for linear regression problem, remember you always have something like xi, yi, data given in this way. So the correlation can be easily computed. Okay. So I want to use a few minutes to review